Okay, so there was an error, and I am just redubbing the narration over this, so it's going to be a little bit awkward sometimes and after the fact, but we'll try to keep it up. So we're not going to deal with circles on this one. We're just going to learn how to use graphing calculator to help us solve systems and find the equation of a parabola. Now, this XYZ here, we could do that with elimination and substitution like we did with the X and Y 2 by 3, where this is a 3 by 4, and we're going to learn how to use a calculator to make life way easier. Okay. Now the important thing is to remember that we call it a 3 by 3 system, but the actual dimensions of the matrix are very important. And this is the matrix; it's just an array of numbers, but we have to list them by rows times columns. So RC, that's very important to remember. RC, like remote control, or RC cola, because you have to count how many rows there are. So in this case, there are 1, 2, 3 rows, and then 1, 2, 3, 4 columns. So this is a 3 by 4. That will come into play with the calculator in a little bit. Okay, so when you're doing this, you're going to use what's called a matrix in the calculator. So always clear out of anything you're in. So if you're in something like that, a list, make sure you hit second quit to get clear, and then you hit second matrix, which is that button right there, 4 down, and then we're going to go right over to math, and we're going to go, it's faster to go up to B, R, R, E, F. Don't go to A, go to B. We want R, R, E, F, ref, not just ref. Once you're at this point, you're going to hit alpha solve, the green alpha button, and then the solve button, which is right up at the top in the middle. And here we're going to enter in 3 by 4. So 3 rows. And down there, go over right, hit enter. And then you're going to arrow back down to OK. And then we'll be in this situation where we're going to enter those numbers that we see right there. Now be very careful to make sure you double check on negative signs. Make sure that all the numbers, you enter them right. You don't accidentally hit a wrong button. Happens all the time. I do it. Okay, I've done it in videos on this lesson already in the homework. So double check as you go. You can do one row, then double check. You can do each number and double check. You can do the whole thing and double check. What's important also is make sure when you enter a number, don't hit enter, hit the right arrow. If you hit enter, it'll just solve it, incomplete, and you'll have to start over. So we're entering every number as we go along, and then once they're all entered and we've double checked that all the numbers are absolutely correct, we hit enter. And there's our solution. Those 3 numbers on the right. And you have pictures of all this, but there it is right there, -4, 3, 3. So that's x is -4, y is 3, z is 3. That's what that means. So we're going to always write, this is how you show your work. This is called an augmented matrix. So you're going to write out all the numbers, the coefficients, and if there's no coefficient, it's 1, or possibly -1. Okay? That's what it looks like. We just took all the numbers from the problem and write it out. I'm going to show you on this one also. So 1, 5, 3, 4. Now notice there's no number here, so we put a 0 because there's 0 x's. Then 4, -1, 3, and then 6, -2, 4, and 0 because we have a 0 there. And then we just do the whole process again. Once we're here, we go to alpha zoom. It's already set up, so you just arrow down to OK and enter right into it. And put the 12 numbers in slowly and carefully with double checking all along the way. Now at this point, we again want to double check all the numbers and make sure they're right. when we hit enter, and there's our answer, 1, 3, 1. So we have two ways to write that. We can say x is 1, y is 3, z is 1, but we can also put 1, comma, 3, comma 1 in parentheses. That's a spot, that's a location, a point in three-dimensional space. It has height, width, and depth. So again, doing the same thing, same procedure, getting into that matrix, edit, go right to OK, boom, put the 12 numbers in. 1, 5, 3, 4. Keep hitting right arrow all on the way. You are going to accidentally hit enter and have to start all over. I still do it. It happens. We're kind of used to putting in numbers and hitting enter, so. And once you get a -6, -2, 4, and 0, check everything, hit enter, and there it is. And it just happens to be decimals, and that's okay. So x is 0.25, y is 0.75, and z is 0. So that would be the 0.14, 3/4, 0 on the z-axis. Now, when we get into 3 and 4, we have special situations, which we've talked about before. Infinite solutions means that it's a line on top of a line. Every point is touching. And the calculator is actually going to spit out a special answer here. So we make our augmented matrix. And again, always make sure your x, y's, and z's and your numbers are lined up properly. Nothing has to be moved around. Once we do our augmented matrix, we're going to go through the same procedure and enter everything into the calculator. But this time we know we're going to get infinite solutions. Okay? We're not going to get, like up here on the right, a diagonal of ones. Okay, that's the proper for one solution. The one's diagonal and then the numbers there on the right, whether it's 2 or 3 numbers, depending on what we're solving for, however many variables. So, same procedure here. Get back up into RREF, alpha zoom. And enter the numbers. Pay extra special attention to the negatives. Again, right arrow all the way. Now when you hit enter for infinite solutions, the bottom row is going to be all zeros. There you go. When you get all zeros in the bottom row, it means infinite solutions. They're all the same line. And if you look at the 3 equations, if you take the first one and multiply by -3, you get the second one. If you multiply the top one by 2, you get the third one, which means they are all equal to each other. They're all the same line. And what I don't do here, I should have written down, is you need to write down the answer is infinite solutions, which you can abbreviate, INF-SOL. But again, 4 zeros, all zeros in the bottom means infinite. And then we're going to get into the last one here. So 3, 24, 9, 9, 1, -8, -3, 37, and 2, -16, -6, and 75. Now we're going to have no solutions, which means all these lines are parallel. They don't intersect ever. They are parallel to one another, generally. Or you have these other situations where 2 intersect, but the third, they all don't intersect. So that's what these other little drawings are. So we're entering the same way we had before. But we could have 3 parallel lines. We could have a little tent, like a capital A. Or we could have like the 2 shelves there with 1 piece going through. So there is some intersection, but not an intersection of all 3. That's what it means here when you have 3 dimensions. Two of them may intersect, but not all three at the same point, and that's what it means. So we're putting the last set of information in here, 2, -16, -6, and 75, verifying that they are all correct. And once you do this and hit enter, notice what happens. Now, in this case, you get 3 zeros and a 1. And it was on the last row, but it doesn't have to be on the last row for no solution. Okay, so infinite solution was the bottom row was all zeros. I'm telling you this because in your assignment for this lesson, you actually do have one where it's 0, 0, 0, 1, but on the second row. Okay, now moving on to parabolas. F of x also means y. Now I don't draw it here, but I'll talk about it in class. I suggest you move the y to the back end, to the right side, because when we enter in the matrix, we put it on the right side. And sometimes people get confused. So I just move it to the right. So I do ax squared plus bx plus c equals y. Now, all we're doing is writing the 3 points separately. And basically, wherever there's an x, we're going to plug in the x value, 3. And wherever there's a y, only one spot, we put 20. And the c is always going to be 1c. Okay, because we're not, that is a constant, not a coefficient. Okay, so we're going to do that with 320. Okay, then we're going to move on to -1, -4. -4 is our y value. I again would move it to the right side, but that's okay. Then we plug in -1 wherever there's an x. Then we're going to do the same thing with -5 and 4. Now, once you plug those numbers in, you're going to crunch the numbers. So 3 squared is 9. -1 squared is 1, not -1. Be careful. And -5 squared is 25. And once we have all those numbers crunched, we're going to then enter them into our augmented matrix, which we've already done before. Now, when we do this, I just skipped the steps here, there's your answer, 1, 4, -1. But in this case, we're not solving for an intersection, so it's not the point 1, 4, -1. We are actually solving for the coefficients and constants, the letters in the equation for a parabola, ax squared plus bx plus c. So the first number is a, b, c. We're not solving for x, y, z like we have in the past. We are solving for a, b, c. And then we just plug them in. 1x squared plus 4x minus 1. But the beauty of this is we can actually check and see if we're right. We can plug that in to our calculator in the y equals, go to second table, and look up those 3 points. And if those 3 points are in the table, that means we found the correct equation. And it has to be all 3 points. I made a mistake on one, and 2 of the points showed up, but not the third. So you have to make sure all 3 points are there. But that's what we're going to do right here. And there's 320. And all the other points are going to be right there. And that's it. We know it's right. Now we're going to do one more. So there's our 3 points, -220, 1, -1, and 2, 0. So we're going to write those out. And then we're going to plug them in. So again, there's our equation. I would again write ax squared plus bx plus c equals y. Just to remember to move those numbers over to the other side. That just makes it easier. But here I am plugging in the y's. I could also plug them in on the right side first before I get started. And now I'm just substituting in the -2. So -2 goes there, squared. Here comes the b with the -2 after it, and 1c as usual. And again, it's -2. And then 1c. Okay? Then we're going to plug in the 1's. So a parentheses 1 squared, B parentheses 1, and again 1C. Now we're going to plug in the 2. A parentheses 2 squared, B parentheses 2, and 1C. Now we're going to crunch the numbers. So negative 2 squared, again, is not negative 4, it's positive 4. So 4a minus 2b, you can also put plus minus, plus negative 2b, it doesn't matter, plus 1c. Then we're going to do the next one. 1 squared is 1, 1 is just 1, and 1c. And then last but not least, 2 squared is 4, like the first one, except this time positive 2b and 1c. Now that we have all of our numbers, we're going to make our augmented matrix. Again, remember, the y's go in the last column, so be careful. Maybe if you do it this way, at least do this and write them in first. And then we're going to put in 4, negative 2, 1, 1, 1, 1, and 4, 2, 1. Now we just repeat the whole procedure. Get our calculator out, go into second matrix. Again, in the table here, make sure you hit second quit to get out of that. So second quit. Now go into second matrix, math, RREF, and we're just going to enter it in as we go, as we've been doing. And then at this point, once the numbers are all in and double checked, then we're going to put all those in, confirm they're all correct, and then enter, and we'll have our 3 numbers for our equation. 2, negative 5, 2. And once we do that, I write them down, and I go right to my equation. Y equals 2x squared minus 5x and plus 2. And again, the last thing you can do to be safe, better safe than sorry, is go into your y equals. I try to be quick about this and had a blunder, so I'm going to reset this here in a second. Realize I shouldn't. I'm trying to be cute with it and just clear it out and start it over. So here I go, 2x squared, negative 5x, plus 2. Hit second table, confirm all those points. And once I confirm all those points, I am finished, and I know I did it correctly. And when you have the time, there's no reason why not to do that. And that's pretty much it. Plain and simple. Saves a lot of time, makes your life a lot easier solving these things.